Okay, friends, so here are the results from Max's little die experiment. So you got 18 ones, 17 twos, and so forth all the way down. I decided to make a pie chart out of them with percentages as labels. I thought that was kind of a nice, complete way of looking at the entire data set. And we got the most, looks like fives and ones. Yeah, and then the least fours, which is interesting. Again, random. You don't really ever know what's going to happen on the next roll. So, for example, if I look back here, this die right here is 5. If I try to guess what's going to happen when I re-randomize, I'm going to guess. You know what I'm going to guess? I'm going to guess 5 again. Hey, look, it was 5. I'm going to guess 5 again. Oh, it was 3 that time. I'm going to guess 5 again. I'm going to guess 5 again. I'm going to guess 5 again. I'm always going to guess 5. I'm always guessing 5. Now, if I use the strategy, I'm always guessing 5, I'm only going to be right when that's 5. However, what happens in general over a long period of time? Now, here's the good news. Every time I was pressing F9 and recalculating all these results over here, every single time I was doing that, on this sheet over here, Excel was actually keeping track of how many of each of these pips we got. So every time I pressed F9, you're noticing this cumulative column is going up. Now, what you're seeing over here, I'm going to add maxes in a second. What you're seeing over here are the total numbers of 1s, 2s, 3s, 4s, 5s, and 6s that have been seen over time. And for a second there, 1 and 2 were exactly the same. That was actually really cool. Over here is a pie chart of the results, just like it was before. Okay. You might look over here and go, wait a minute, these slices look identical. They all look like they're exact. Like these lines look like they go straight through. And they do to some degree. These are rounded off to 2 decimals. However, if I change the rounding a bit more and give it, say, 5 decimal places, you see that they're not exactly 16 or 17%, 16.3%, 16.9%, 16.4. And again, if I let this thing sit here and keep on doing what it's got to do, it's going to begin to stabilize even more. The question is, they do appear to be approaching the same value in each one of these slices, approximately about 16.666%. And we'll get into more of that later. Okay, I'm going to take these back to percentages like they were before. Okay, now I want you to watch these percentages, because what I'm going to do now is I'm going to take Max's data and I'm going to copy it in and drop it in. I'm going to, on 3, I'm going to paste it in. You watch that pie chart and see how much it changes when we add in Max's data. 1, 2, 3, go. Did you see it? Did you see it? It changed. It was just extraordinarily small, because Max only ran his, what do you got, a sum of what, 97, just about 100 dice here. Just about 100 dice. That's no match for the 25,000 or so we have here. So what you're actually seeing over here in this pie chart, as we already discussed, are these percentages. Poor Max, his little results here barely make a dent in the overriding percentages. And what you actually end up seeing is you see effectively these percentages beginning to stabilize, which at the end of the day, you knew that was already going to happen. That's why people use dice. People use dice because they are a perfect random number generator. They're actually a better random number generator than even Excel's random number generator, because Excel's random number generator is not perfectly random. It's only called pseudo-random. Don't worry about that right now. We might talk about it later. But here's the deal. If I was to ask someone to write down 11 rolls of a dice, do you really think they're going to write 2 for the first 3? Do you really think they're going to have 3 6s within the last 4? I mean, does that seem random to anybody? How about now? If I ask somebody to write down 11 random rolls of a dice, do you really think they're not going to have any 3s in there? Right? These are all random rolls of 11 dice. But I mean, look at this. This is a great one. It's got 5 5s, 4 of which are in a row. So you have to ask yourself, man, is Sean just that good that he's managing to stop these things exactly where, quote unquote, something interesting happens? And my answer is, oh my goodness, no, not even close. Not even close to that. What we're looking at here is the way that randomness behaves. It behaves in clumps. It behaves in clumps because the overriding thing to look at, this pie chart, for example, there's an underlying overriding kind of truth to what's going on in random processes. If I stop in a second and try to guess how many of those dice were 3s and 4s and 5s, I would fail miserably, because there's no way I would guess that there'd be 3 1s in the middle right there. But yet we've seen 3 in a row a number of times. It can't be that rare if we see it a number of times. So randomness, kind of by definition, is unpredictability. But what you also seen in this little video here is that there's an underlying regularity that happens over the long run. And that's, I think, a good place to look at our last video and then move into some homework.